Hey everyone. So the first video this week, what we're going to be doing is diagram problems and learning how to use the calculator to evaluate trig values. But before we do that, I do want to do another example from like the end of last week's second video, which dealt with SOHCAHTOA, just so we can do more than one. And I wanted to do this example I have here because I wanted you to know that the right triangles aren't always going to look the same. Some of them can be, the right angle can be in different spots. You could have something that looks negative as well. All right, so if you have something like this and our angle is right there in the corner, then I want to know all 6 trig values. So I want to know the sine, the cosine, the tangent, and the cosecant, the secant, and the cotangent. Now remember, once you figure out the first 3, these last 3 are very easy. You just flip the fraction. But the first step into doing this is to use Pythagorean theorem, because you have a missing side here. We need to figure out what that side is. All right, and that side is going to be 1 squared plus 2 squared. So 1 squared plus 2 squared equals 1 plus 4, or 5. So my c squared is 5. So that means this missing side is square root of 5. And so now we just use SOHCAHTOA. So sine's opposite over hypotenuse. So opposite 1 over root 5. Which means cosecant is root 5 over 1, or just root 5. Cosine, adjacent over hypotenuse. So adjacent's going to be 2. Hypotenuse root 5, which makes our secant root 5 over 2. Now, do I care about you rationalizing the denominator? I don't remember if I said it last week or not, but you don't need to. Okay, it's okay if you leave it this way. I do want you to simplify them if you can. All right, tangent, opposite over adjacent, so 1 over 2. Therefore, cotangent's 2 over 1, or just 2. All right, so hopefully these examples really aren't too bad, and your homework wasn't too bad either. But these are actually going to be the basis of some special triangles we're going to be talking about. And these kinds of triangles I would expect you to be able to do without a calculator. All right, these are special triangles. And in geometry, you talk about these triangles, the 45, 45, 90, and then you have a 30, 60, 90. Okay. Again, these triangles can be drawn different ways. They don't necessarily need to be facing this way and whatnot. But this is a 45 degree, 90. All right, they have congruent sides. It was a special triangle that you did in geometry. The other one here, this is a 30, 60, 90. All right, now the sides of these triangles never change. Okay, some teachers, I think the MCAS cheat sheet has it as x, and x root 2. But for this class, it's really going to be easier for you to just leave it as 1, 1, and root 2. Okay, because you have 1x, and x root 2. All right, so we really don't need those x's. Let's just go with 1, 1, root 2. This other one, again, MCAS probably had it with x, x root 3, and 2x. But wherever there's an x, we're going to replace it with a 1, just like we did on the other triangle. So we really are going to have 1, root 3, and 2. So these two triangles, if you take calculus, you're going to be expected to know these, like bam, in the blink of an eye type of deal, okay? Because when you're trying to evaluate areas under curves or some kind of shape, you need to evaluate the area and you only know the angle, or if you're figuring out how fast the angle is changing and stuff like that, it's going to be needed. So the kind of examples that you're going to have. Dun, dun, dun. Let's draw a triangle. We're going to do a 30, 60, 90. Okay, so here's this, and we'll connect the dots. Let's do a Y, an X, and a 10. And it says this is 30 degrees. Okay. Well, this, if I want to know, hey, what is X equal to? What is Y equal to? Well, like I was telling you before, the MCAS thing leaves this as 2x. And this is x root 3 and 1x. Okay? So therefore, if it's 2x is 10. Remember, this x here is different from the x on the triangle up top. But that would mean that this side next to 30, the adjacent side there, would be half of that. No, not half. Sorry. Y would be half of that. So y is going to be 5. Again, that's because the hypotenuse of a 30, 60, 90 is 2 times something. And 2 times something equals 10. That something is 5. Okay? This missing side, I'm going to have to take that number, that was my opposite, and put it next to a root 3. Okay? What we're doing is we're really just making similar triangles. Because if I was to plug these in, this 5 here for y and 5 root 3, we would have similar triangles. Alright, so let's try another one. I'm going to go this way now. And we'll connect the dots. Bam. Alright, so let's say we have a 60 degrees up here. Alright, and we'll do X, Y, and 12. Notice here it's definitely not drawn to scale. Okay. But again, you still use that same triangle as reference. Okay. I'm just going to bring it down so we can have it on the same spot. Half of the hypotenuse is always the smallest side. Now the smallest side here, well, if that's 60, that's 30. The smallest side, remember, again, back from geometry, is always opposite the smallest angle. So that means x is my smallest side. So that means x is going to be equal to half the hypotenuse, or 6. Which makes y, whatever that was, plus a root 3. So 6 root 3. Ta-da! Okay. Let's do another one. Watch that Disney sing-along there. It was meh, you know. I think the Hakuna Matata was probably the best thing they did. Alright, so this one, 60 degrees. Let's say we need to know that side, this side, and we know this side's 20. So now I'm actually like making you work. Okay, so that's 60 degrees, this is 30 degrees. We do not know the hypotenuse this time. But, again, using this triangle, I'm going to drag it on down. Okay. I'm just going to rewrite it as x root 3, and 2x. So opposite 60. Opposite 60 is x root 3. So that means 20 is going to equal x root 3. All right. We want to make sure our x's coincide with the triangle we're dealing with. So that would mean divide both sides by root 3. Shaboom, boom, boom. X in this case is 20. Let me write, come on. 20 over root 3. So over here, that's opposite the 30 degrees. That means opposite 30 degrees is x. X is 20 over root 3. The hypotenuse is always 2 times whatever the smallest side is. So I got to do 2 times 20 over root 3 or 40 over root 3. And that's your answer. Dun, dun, dun. Oh, I guess remember me was good too. I think we're going to do 45, 45, 91 because we got to do one just to say we did because they're rather easy. Let's go this way. I don't know if that's even close. It looks all right. So what I'm going to do is I'm going to put a boom congruency marks. You might not even have the angle measure. But I'll say that's x and that's x. And I want to know what x is. Well, in 45, 45, 90, I said 1, 1, root 2. But remember, that's the same thing as saying x. Let's make that an actual x. 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 X root 2. So that means x root 2 is equal to 14. Divide both sides by root 2. And x equals 14 over root 2. Could you simplify that if you really wanted to? Sure. You could rationalize the denominator. Are you going to have to? If you want to, that's great. You'll get 7 root 2. Either answer is totally okay. All right, so basically those 30, 60, 90s, 45, 45, 90s triangles are going to be very, very important for our next lesson. Is it the next lesson? Yes, for the next one. Yeah. So have those two stuck in your head, whether or not you use the x's or the ones. Personally, I use both depending on the kind of questions that we're doing. So let's do like the next part of the lesson. The next part is diagram problems. These aren't with no special triangles in this one. Right, these are where we're going to actually have to use the calculator. So hopefully you have your calculator with you. One thing to note is you want to make sure you're in degrees because we're dealing with degrees right now, so we would check that on these calculators. You hit mode and look at radian is highlighted, and I don't want that, so I'm going to come over and hit degree because that's what I want. If you have a calculator that doesn't look like this, oh yeah, we on it. Because look, it's 8:45. Oh yeah. So if you don't have a calculator like that, just make sure your calculator says DEG or it has a D symbol and not an R or RAD. Okay. So B in degrees. Ugh. That's huge. All right. Let's draw a triangle. Let's connect this triangle. Let's give it some angle. Let's say I have 43 degrees. See, 43 degrees is not a special triangle. And we know that side's 12.5, and this is x. And I want to know what the value of x was. Well, what you need to do is base everything off of this angle. Based on this angle, what sides do I know? Well, based on that, I know my opposite side. And I want to know my adjacent. Okay. So, you look at SOHCAHTOA. And you're thinking, well, which ones use opposite and adjacent? Whoa, spell it right, bro. its tangent. So that means the tangent of 43 degrees is 12.5 over x, and then we would solve for x. So x is really 12.5 over tangent of 43 degrees. You grab your calculator, you type it in. Be careful with parentheses, make sure you close them and whatnot. So this one we get x to be around 13.4. Decimal points round to whatever you think is best. I don't know. You could really use whatever you want. But all right, so let's do another one of these. Again, pause the video if I'm going too fast. But I know you watch it in halftime. Or not halftime, double speed? I don't know what the heck it is. You watch it faster than normal. You know who you are. Now let's make this 22. And we'll say this is 18 degrees. So, again, we want to know what x is. So we have to base everything off that angle. We do not know the opposite. So we're not even going to deal with that. However, we know the adjacent and the hypotenuse. So, everything's based on SOHCAHTOA. We have the adjacent and hypotenuse. Adjacent hypotenuse looks like cosine. So the cosine of 18 degrees is adjacent x over hypotenuse 22. And again, if we want to solve for x, we would multiply both sides by 22. You get 22. Cosine of 18 degrees is x. And then you grab that handy dandy calculator. But you got to put 22 in. And you get 20.9 for x. So you could use this to find missing sides of right triangles, which is really nice. This is actually something that I've used when I've tried to see how tall something is, like in the backyard. If I'm trying to see if I can take down a tree and have enough room to do it, what I do is I actually, you got your tree here, whatever. Okay, here's my tree, and here I am over here. All right. Well, just draw a dude, man. Come on, man. Here I am looking at the tree. Got my little hat on. And what I use my phone, and your phone, I don't know if you know this, but it has an angle kind of thing. Like I think it's in the level or the measure, maybe a compass or something. But what I do is I measure, find the angle to the tip of the tree, and it will give me like this angle here, which is kind of cool. And then what I do is I measure the distance from me to the tree, and I don't know, let's say that's 20 feet. And I know that I'm short, right? 5 feet, 6 inches tall, right? Very short. So I can say, well, I'm 5 foot, 6 inches. And again, this would be ballparking. So I could ballpark and round up to 6 feet and say I'm 6 feet tall too. But that'd be a lie. But what I would do is I would use the tangent. And I would know the tangent of that angle is going to be the height of my tree over 20. And it's kind of cool. So that'd be like the height of the tree over 20. And then what I would do with whatever x is, so I'd get x to be 20 tangent of whatever the angle is, I would end up adding my height to it. So plus my 5 feet, 6 inches. And then I could figure out how tall the tree, approximately how tall the tree is. Kind of a useful thing to do. Is everybody going to do it? No. Is it that's something I did in high school actually. In my physics class, we made water bottle rockets, and we determined how high they went based on something like this. But yeah, let's do another diagram. Yeah, sure, let's go like that. We'll say this is 50. Ooh, that's definitely not a 5. Crap. 51. And let's say hypotenuse is x. And this triangle's drawn horribly. Let's say this is 15. Okay. So, I want to know x again. Well, I know the opposite. I know the hypotenuse. So that again means we're going to use whatever uses O and H, and that's the sine. The sine of 51 degrees is our opposite 15 over a hypotenuse x. Then we solve for x, so we get x to be 15 over sine of 51. Grab the calculator. Get 19.3 for x. All right. So once you figure out again one side, you can use Pythagorean theorem to find missing sides. Because you now have 2 missing sides, you can use the 2 to find a third. Gotta take a drink of water. All right. Finding missing sides, not sides, angles. There's another thing you can do with diagrams. So, let's say you have a right triangle. How far am I? I don't know if my clock is still running. I set a stopwatch, but I set it late. Okay. So, let's say this is 80. This is 100. And here's my angle. And I want to know what the angle is approximately, all right, in degrees. So everything, again, is based off that angle. We know the opposite. We know the adjacent. We go back to SOHCAHTOA. Only one of them deals with opposite and adjacent. And that's tangent. So tangent is opposite over adjacent. So to figure that out, you use your calculator, and if you notice, right above tangent, cosine, and sine, you see this sine to -1, cosine to -1, tangent to -1. This is what we call the arc sine, or the arc cosine, or the arc tan. This gives us the angle based on the sides of the triangle. So if I give it the sides, 80 and 100, it will give me the angle that has that as tangent. So this is 38.7 degrees. So to plug this in, again, use tan to -1 of 80 over 100 equals our angle. All right, let's do another one of these. Well, it looks like a 45, 45, 90, but it's not going to be, okay? Shoot a pie. Oh, yeah. Yeah, so 14.5 and 6, and I'll throw the angle up there. So again, everything's based off the angle. So we know the opposite. We know the hypotenuse. The opposite in hypotenuse is sine. So 6 over 14.5. Which then means we're going to plug in the arc sine of 6 over 14.5, and we'll get our angle. The arc sine, 6 divided by 14.5. And I get 24.4 degrees. So that's nice too. But yeah, those are your basic diagram problems. You can use all those methods to do any word problem, to solve any triangle. Eventually, what's going to happen is I'm going to ask you to solve the triangle, which means all sides, all angles. So you're going to have side or angle ABC, side AB, AC, BC. Oh gosh, it's not even that late. I'm this tired. God. All right, let's go back to some calculator stuff. Calculator. That's, oh my God. Calculator problems. All right. This is you just plugging things in and making sure you get a decimal. Like the correct decimal. So the cosine of 221 degrees. Plug it in. We'll just do a bunch of these because they're really not going to take too long. The sine of 178. This one's tricky to plug in. The cosecant of 130. Those are going to have to be very careful plugging those in. The cotangent of 243. All right. Cosine, to plug that in, you really just hit the cosine, and I'm going to put 221. Again, since I'm in degrees, that's my answer. Negative 0.755. Let's put that 3 decimals. All right. The next one's sine 178. 0.035. Okay, one thing I want to point out to you guys, sine of any angle is between -1 and 1, and that also goes for cosine. Okay, it's just it's a fact. Okay, so it means you're going to have a decimal either way. So cosecant. The cosecant is the reciprocal of sine. So that means we're going to do 1 over the sine of 130 degrees. So there's a few ways to do this. You can really plug it in, 1 divided by the sine of 130. And you get your answer, 1.305, which is right. But not everybody has this calculator. You might have, if you're using your phone, you're going to have to do 130, then sine. Your phone has to be turned sideways, by the way. And then you're going to have to hit that 1 over x button. I'm going to check it on my phone right now, just to be sure. Again, I'm using an iPhone X in case anybody's trying to give me grief. Yeah, so that's the step you would have to do. There should be a button that says 1 over x like that. But those are simple calculators. If you can plug it in like that, that's great. You can use Desmos as well. I think Desmos actually has those things built in. Cotangent. Cotangent's 1 over tangent. So 243. Grab the calculator, plug it in, 1 divided by tangent. 243. Close that parenthesis. Bam. 0.510. Alright. Now, if there is no degree symbol, this is huge. If there is no degree symbol on the problem, you must assume we're in radians. Therefore, you would have to change your calculator. So if no degree symbol, use radians. Right, that's huge. So that means my next one, which I have the cosine of 2.56, no degree symbol. That means I'm in radians. So I go to my calculator, and I have to change it. Make sure I'm in radian. So I'm going to do 2.5. Oh dear, you have the first hit cosine. 2.56 and negative 0.836. Alright, let's do another one. The cosecant of negative 0.751. And let's do the last one. Secant of, let's say, negative 15 pi over 8. If you ever see pi, you kind of know you're in radians. But cosecant, again, is 1 over sine. So 1 divided by sine, negative 0.751. There it is, negative 1.465. Alright, the secant is 1 divided by the cosine, negative 15 pi divided by 8. So here I get 1.802. Alright, cool beans, cool beans. Alright, so hopefully those things aren't too bad. I did have a few other things to do, but I think I'm going to save that for the next video because I'm not really sure how far I've gotten. Yeah, only because it's getting late and I'm getting tired too, and it's really not even that late. It's 9 o'clock. But I was up at like 4 o'clock this morning feeding my kid. So let's call it quits on that. I look for the next video, and we'll continue this. Basically, the next thing we're going to be doing, these things, like I said, called, we're going to introduce some identities, but we're not going to call them those yet. Then we're going to use a point on the terminal side of an angle, blah, blah, blah. There's all these fancy words, and I'm going to ask you to find the value of all 6 trig functions, which really just entails you using Pythagorean theorem, finding missing sides, using SOHCAHTOA, stuff like that. But yeah, and then we'll get into these things called corner angles. I'm not quite sure if we're really going to graph these functions. That's a huge part of this this test if we were to take it in school, but it's not necessarily needed for calculus, so we may stay away from it. I'm going to talk to my other department members about it. All right, so we'll talk to you guys at the hangout if you choose to come. If not, good luck on the homework.